Another problem for t-test. This time, a cell phone industry manager thinks that the customer daily text messaging have increased, and now the average is over 52 per day. The company wished to test this claim and assume distribution is a normal distribution. Suppose 25 customers are selected with the following results. Sample size 25, sample mean 53.1, and sample standard deviation 10. So let's enter those numbers first here. So the sample for population 52, we are looking for if this is greater than 52. Level of significance is 10%, 0.1. Sample size is 25, and the sample mean 53.1. Sample standard deviation is 10. So again, the population variance or population standard deviation is not known, so we should use t-test. Now the claim is here, it is the text messaging is over 52, so mu is over greater than 52. As you can see here, it is right tail test. It is not anymore like the previous one that was equal or not equal, but this time we are looking specifically if the number is over than 52 or greater than 52. So it is one tail and right tail test because we are looking for more than the population mean. So then again, so you need to bring the right tail. So once we set up our hypothesis, the next step is to find out the critical value. The critical value here for the right tail, the function is t.inv.2t. Now 2 times b5, 2 times b5, and degree of freedom b10. b10 doesn't change because it says n minus 1. It's 25 minus 1, but you can see here we need to multiply the probability by 2. The reason because now this is this is one tail. In two-tail test, we don't need to multiply by 2, but for one tail test, either right tail or left tail, we need to multiply by 2. So 2 times b5. So we multiply level of significance by 2 because it is one tail. This is the way how Excel works. So you just keep in mind, if there is a t-test with one tail, for probability you need to multiply level of significance by 2, and degree of freedom is n minus 1. So when I hit enter or OK here, so I can see the upper critical value or right tail is 3.178. I like to bring the graphic here so we can discuss on the graphic. Let me paste this. Okay, I paste this. So 1.318. So I rounded up 1.3178, so it becomes 1.318. So any number on the right side will fall on reject H0 area or H1 accept. Anything less than 1.318 would be do not reject H0, which means accept H0, reject H1. Now, if you ask what if this is 1.318, the probability is very low to be the same value, but if this is 1.318, it should be H0 because our claim is only more than 52. Well, after we finish the upper critical value So we know the upper critical value. Next step is to find the test value, which we are going to use this formula. X bar minus mu divided by standard deviation divided by square root of sample size. Now here's the cell where I keep the formula B7 minus B4 divided by B8, which is standard deviation. You can see here standard deviation B8 divided by square root of sample size B6. So the answer for this is 0.55. So where the 0.55 falls is on this side, somewhere here 0.55, which means we need to accept H0 and reject H1. That means the daily text messaging is not increased. 90% confidence, with 90% confidence I can tell, based on this 25 survey, I can tell daily text messaging is not increased. It's not over 52 per day.